Hi there, I'm Chris White, and today we're going to be talking about a corpus-sensitive algorithm for automated tonal analysis. What this builds on is some previous work of mine that maps an observed sequence on the surface of a musical corpus onto a reduced sequence by maximizing the relationship between the chord's contexts and their content. And I'll talk a little bit more about this later. But the problem that we're trying to solve
is that when you look on the surface of music, you don't see a lot of complete chords. For instance, in this example, all of those red boxes are the verticalities, and there's just not a lot of complete chords. Similarly, we see a lot of structures like this, which are dissonant, and the computer doesn't recognize that that should be equivalent to a G chord. Rather, it would see it as SOT D. And also, we need to figure out what key we're in. We need to know that that DF is Re, Fa, and C major.
And more broadly, what we're interested in is being able to map from the statistics of a corpus onto the analysis task that we do every day in the music theory classroom. So what we want to do is construct an algorithm that learns Roman numeral style analysis by compiling a reduced vocabulary from the raw surface statistics of some corpus, and then use that vocabulary to reduce and assign key to some musical surface. So what corpus are we using? We're going to use the Yale Classical Archives corpus, which is the surface statistics of about 9,000 common practice pieces. It's a really interesting corpus. I'd encourage you all to look at ycac.yale.edu for more information. But the thing about this corpus is it's very raw. It's just the surface. So if you go down there to the fifth chord there, Do Mi, you'd imagine that a Do Mi would be considered equivalent to a 1 chord, but there's no way to map from that structure to a 1 chord at just the raw statistical level. And so we're going to manipulate the raw statistics to produce a reduced vocabulary, a more traditional vocabulary, by exploiting subset and superset relationships that is scale degree overlap to edit chords in order to maximize the bigram probability of the chord sequence. And this is what we're going to use that initial algorithm for. What this is going to allow us to do is take a structure, a sequence like this, with some incomplete 5/7s going to a neighbor sharp 2 that ends up with an incomplete 1, and map it onto a more recognizable chord progression. So the first thing that we'll do is recognize these subset relationships, that Fa T is inside Fa Ti So, and so is the So Ti of the neighboring sharp 2. We'll also recognize that knocking out Re increases the probability of that verticality. And then if we knock those two things out, we map those onto the So Ti Fa. Then we can recognize that adding Re and So would complete the 5/7 and complete the 1, thereby creating the more probable bigram, a complete 5/7 moving to a complete 1 chord. And what probabilities am I using to judge these bigrams? I'm using the bigram probabilities within the raw statistics, within the Yale Classical Archives corpus. And once we run this process through the whole corpus, we end up with a reduced vocabulary that is far more like what we teach in textbooks. Now we can use this reduced vocabulary to perform analysis, basically assigning Roman numerals. So we're going to select a window of music to analyze. We're going to use the same reduction process, but we're going to do it for all 12 possible key levels, and then choose the key that assigns the window the most frequent, that is most probable chord progressions. So if we take this sample window here, and you'll notice that D goes 1, 6, 2, 5, 7, and that's very probable compared to what happens in, say, A, which is 4 to minor 5, or what happens in D flat, which is basically nonsense. The model would recognize the modulation that occurs later in this phrase because D is no longer the most probable, but rather A produces the most probable sequence of events, the most probable annotations and bigram transitions between them. So the takeaway from this is that an algorithm that learns Roman numerals from the properties of the corpus itself can show the properties of common practice music that we emphasize when we adopt such methods, articulates the assumptions inherent in Roman numeral methodology, and suggests how listeners might learn a musical vocabulary akin to Roman numerals by being exposed to common practice music. What about common practice music invites us to analyze it with Roman numerals? Thank you for your interest in my work. Feel free to visit my website for more information. That's chriswilmwhite.com, and I'm also available during the poster session to take questions via Twitter and Periscope at chriswilmwhite at CHRISWMWHITE. Thank you.